All right, gang, week 2. We just have one more thing of circles that we need to talk about, and then we're going to move on to chapter 11, which is area. But that last bit of circles that we need to address are tangent lines. So we need to start out with the circle. And the way lines can be related to a circle, you can either have the line intersect the circle at 2 points. You can have the line intersect the circle at 0 points. Or you can have the line intersect the circle at just 1 point. So these are the only 3 relationships we can have. When it doesn't intersect the circle at all, like this line here, there's no classification for it because there's no relationship. We don't need to define a relationship that doesn't exist. But the other 2 lines, these 2 relationships, if a line intersects a circle at 2 points, or another way to define this is a line that contains a chord, this is called a secant line. Now you might remember where we had the word secant when we learned about trig. Don't worry about why that's called that. You'll learn about that when you do in-depth trigonometry in your junior year. But this one, that line where it intersects a circle at exactly 1 point, that is our tangent line. That is what a tangent line is. A tangent is a line that intersects a circle at exactly 1 point. Now, important, it's also coplanar. I could have the line, like where that marker is, that intersects the circle at 1 point, but it's not tangent to it because it's not in the same plane. So the tangent line is coplanar with the circle and intersects at exactly 1 point. So that's what a tangent line is. Now there's some special relationships from a tangent line. The most critical being that if you have a tangent line, so if you have a circle and a line tangent to the circle, the tangent is perpendicular to the radius to that point. The tangent is perpendicular to the radius at that point. This is, for our intents and purposes, this is the most critical relationship for tangents. Okay? So tangents are perpendicular to the intersecting radius. So tangents are perpendicular to the intersecting radius. That is the most important property of tangents for our purposes. There are other properties of tangents that are going to come up in other fields. In calculus, when you're working with tangent lines, it's going to be a completely different purpose. But for right now, if a line is tangent, that is perpendicular to the radius at that point. And we can prove this using an indirect proof. I know you guys are thinking, man, we haven't done indirect proofs in forever. I wish we could do an indirect proof, but we're all at home. Don't worry, I got you covered. So let's say we're given circle O, and we're given line L is tangent to that. So we're given L is tangent to circle O. So that's what we're given. What we will want to prove is that OA is perpendicular to L. That's what we would want to show. And the best way to show this is with an indirect proof. And if you recall indirect proofs, we start with an assumption. We assume the negation of the proof statement. We assume the opposite of what we want to prove to be true. So we're assuming that OA is not perpendicular to L. So if they were perpendicular, they would be forming right angles. So that means this angle, I'm going to call it this one angle 1 and that one angle 2. Angle 1 and angle 2 are not right angles because OA is not perpendicular to L. So that means either angle 1 is acute and angle 2 is obtuse, or angle 1 is obtuse and angle 2 is acute, because they're definitely a linear pair. We can tell from the diagram that they're a linear pair because we have line L. So one's going to be acute, one's going to be obtuse. It doesn't matter which one. Let's just say that angle 1 is our acute angle. So angle 1 is less than 180 degrees. So let's say that from O, we drew a segment to say point B. If angle 1 is an acute angle, there exists an acute angle here that's congruent to angle 1. So we could say that angle OBA is congruent to angle 1. There has to be an angle there. Well, if these two angles are congruent, because you can have a triangle with two acute angles that are congruent, then those would have to be congruent as well by the converse of the base angles theorem. OB would have to be congruent to OA. But if OB is congruent to OA, that means B has to lie on circle O. Well, if B lies on circle O, wouldn't L intersect circle O twice? That's going to contradict our given. So we know that if we have a tangent line, the radius has to be perpendicular to that tangent line. All right. So that's the gist of tangents. For us, you'll learn more about them when you take trigonometry, and learn even more about them when you take calculus. But for us, that's it. Have fun.